Is my screen visible?
Yes, sir.
Yes, sir.
Okay, okay. So I'll be dealing with the theory session during this period, and I'll also be taking the fifth hour today. And at that time, I would like you to take your notebooks also. So we'll be doing some problems based on what we studied in yesterday's class. Okay, break-even chart and all we have drawn, and we had studied some formulas, and a few more we have to study. And I will be telling you that in the next class. So be ready with the notebook in the fifth hour. Okay. Some rest of the theory session I'll be dealing with in this hour, and we'll be winding up the first module by the fifth hour. So with the problems, we'll be winding up the first module, and from the next class onwards, we'll be starting the second module. Okay. So in the last online class, we studied about a standardization, and then I briefly told you about simplification. So what was standardization? Standardization was keeping up the standard. Okay. Various standards were given to various products, uh, and that are to be manufactured, or that is to be purchased, or that has to be sent to the market, etc. Were standardized. So some values such as the dimension may be standardized. So it must have this length, or it must have this weight. Okay, these are all some of the quantities, or the physical quantities that are used to standardize a particular product. So, so that is what is meant by standardization. And we had discussed about the needs of standardization. So various needs were there. And then comes simplification. So the idea of simplification is to create a simple design and simple operating procedure for easier manufacturing and less production time. So what was the objective here? We have to design an object with a simple design. That is, it must have a simple design, and the procedure to make the device should also be in a simple manner, so as to reduce the production time and increase the manufacturing products. Okay, we have to reduce the production time. So how much you can reduce the production time of a single product, that much more products can be, so many products can be produced in a single day. So if you are reducing the production time, you can increase the amount of manufactured products. Okay, that is the importance of simplification. So we know that in an industry, time is money. So we for every each and every time, we have to utilize the work that is to be done. So there is no wastage of time. If so many processes are there in a development of a product. So first will be designing. So I have already told you various departments are present in an industry. So in an industry, when various departments are present, each department takes a specific amount of time for doing each of the work. So I have told you about a designing phase. So people come up with ideas and they are designing it, and the other times the during that time other departments are free, so they are not doing any work. So to involve them also, we are involving basic groundwork of the of each of the departments. So various works will be given to the other departments, so as to meet up the wastage of time. So there is no wastage of time. So if one process is taking a longer period, then another product process is done in the industry itself. So an industry has many functions. It must not have only a single product and all. There is so many products it can release, or so many functions are there, and allotment of each and every work is done in a industry. So such a complex arrangement of a industry, if it is very complex, we can't even achieve the particular production, or we can't even achieve the particular manufacturing. So there will be problems in the producing of the products. So for that purpose, we are simplifying each and every operations, or simplifying the design of the product so as to easily make the product. And also, if there is a new labor coming in, so a worker that is present inside the industry need not be fully present during the life of the industry. Okay, the industry may be lasting for a longer period, but a worker need not have to stay in a particular industry for a period of time. Maybe he works for a year, maybe he works for 5 years or 10 years. After that, another worker arrives, or another labor arrives, and he has to take the place of the said worker. So if he is taking the place, he should also know what work has to be done, or how the operations has to be done. If a complex operation is taking place, skilled laborers are required. So for that, we have to, it is very hard to find a skilled labor. So particularly experienced person for that purpose is very low. So if you guys itself pass out from the BTech stream, you are freshers, right? So when you're going to an industry, the industry has, or the industry obtains more freshers than experienced people. So that is what is the common logic here. So when such a worker arrives, a fresh worker arrives, he or she must does not know the work that has to be done. So he or she must be able to understand the operations and the work he has to carry out. And for that purpose, each and every operation is simplified so as the next worker can understand it. So that is what is coming under simplification. So that is one of the type. Similarly, the production cycle, or the products, the component of the product, or the assembly of the product, all are different fields of production, or different fields in the production field, and each and every process is simplified by means of an industrial engineer. So he studies what are the operations that is taking place inside an industry, and then reduces or simplifies the said design, or the operation, or the procedure, or the amount of products, etc., and then does the production. So that is what is a simplification means by. So a general simplification diagram is shown here. So you can see, if an artist is drawing a apple, he will be drawing it in this manner. But if a regular person draws it, it will be in this manner. So that is what is simplification meaning. So there are various levels of simplification, and the most simplest diagram, or what you can understand, is this one, while this one is more complex. Okay, so that is the basic idea of simplification. So if you are taking an example of a fax machine, so in a fax machine, there are two parts. One is the reader part, and one is the printer part. You can see here the reader part, and the other one is the printer part. So in the reader part, where another person sends you a document, or a file, and this is read inside a reader part, or you are feeding into the reader part a printed document, or a document that has to be sent elsewhere. So for that purpose, the reader part is present inside the fax machine, and then other part is the printer part. So in the printer part, we are in the printer part, the documents that is sent by a sender or another person is then printed out and obtained as output from the printer part. So that is how a fax machine works. So you can see from the figure itself, there is many components here that you don't have to bother about. Just look at the stepping motor that is provided here. There is two stepping motors that is provided here. Okay, one of the way for simplification of this system is by combining the stepping motor for both of these part. So you can see the stepping motor here for the printer part is a separate one, and we are providing a separate motor for the printer. And for the reader part, we are also creating another stepping motor, and two separate stepping motors without any correlation is present in the reader and printer part respectively. So when you are simplifying that, we are doing nothing but we are providing a common stepping motor. So you can see here itself, there is a common stepping motor, and from the drive of this stepping motor, the printer roller and the reader roller rotates. Okay, it's a roller. So this is the document or the paper that is shown here. This is the paper. Okay, here also this is the paper. So it is written as recording paper, or the document is written here. Okay, so the paper has to be rolled inside a roller. So that is how one is the image sensor in the reader part, which senses the image and then relays it to another fax machine, while in the printer from a thermal head, the image that is received is then printed out on a paper. So that is what is done, and after the paper is rolled out from the printer, and that is obtained to us. So for that purpose, the rolling of the plate and the roller and the reader roller is done by the stepping motor, by a single stepping motor. So that is how it is simplified. So this is one of the examples for a simplification procedure that is done. Okay. Next category is diversification. So what is basically diversification? Diversification is nothing but it is the condition of having or composed of differing elements, variety, especially the inclusion of different types of people in a group or organization. So that is what is the meaning of the term diversity. So we are involving various designs, right? So various designs may be present. If we are coming into the designing department itself, various personnel are present inside the designing department. Each and every person or the personnel may have any idea. So many ideas will be present, and each and every person may have a particular idea for the design of the said function of the product. So each and every person relays their ideas and pools this knowledge, and then a common idea or a common strategy is then devised for the production of the product. So diversification in the matter of ideas is one of the category here. So another category is that the designing of the product. So various designs can be given to the product. So that is another diversification. Now another is the gender of the person that is done. So a male personnel or a female personnel, that is also another diversification. And there will be races, various races, caste, etc. These are all coming under diversification. Then the operating procedures. So various operating procedures will be included in a production process, and many cycles will be run to find out the optimum or the most simplified procedure for the production process. And for that purpose also there is diversification. So how did this diversification occur? This is because each and every personnel or an industrial engineer designs various operations or procedures that has to be done for the production of the product. So during this period of testing or during the period of prototype testing, prototypes are formed by various operations of the production cycle, and each and every operations are evaluated, and the various order for the operations to be done are studied, and what are the simplest way for the operations to be carried out or without any lossage is studied and then utilized in the production cycle. And this all arises from the diversification field inside the industry. So these are the three categories that we have discussed. So standardization, simplification, and diversification. Next is another topic, it's called concurrent engineering. So what is basically concurrent engineering? It states that it's a work methodology emphasizing the parallelization of tasks, which is sometimes called simultaneous engineering or integrated product development using an integrated product team approach. So what does this one say? So it says that we are parallelizing the task. So we have heard about a term known as multitasking, right? The same function is done in concurrent engineering. We are performing tasks concurrently or parallelization of tasks. So when one task is done, another is done separately for the same outcome itself. So that is what is known as concurrent engineering. So it refers to an approach used in product development in which functions of design engineering, manufacturing engineering, and other functions are integrated to reduce the time required to bring a new product to the market. So the main aim or the goal of concurrent engineering is to obtain or develop the product with the sufficient functions by reducing the time required to produce the new product to the market. So that is what is done here. So we are using a production development cycle or a production development operations and procedures for producing the product, and these are studied, and we are integrating functions or integrating processes that reduces the time and incorporates the faster production of the product. Such an engineering is called as concurrent engineering. So it will be done in a faster way. So here various operations may be deleted from the original cycle, such as a longer period of testing cycle or a longer period of prototype forming or the longer time of beta version production or the test. So various operations or various time for each and every fields will be reduced, and then faster methods for producing the products will be done. So it doesn't mean that is the ideal process. Okay, both the processes are done. The original process for production are also done, and the concurrent engineering part of the production is also done. Okay, this is because at some times we have to produce the product very fastly, maybe to attain or satisfy the demand of the consumer. That is the function of concurrent engineering. So an example is that you have all heard about space rockets, right? In space rockets, we are sending people or products, goods to the maybe to the International Space Station or to various satellites, etc. Okay, and once we are doing if we are doing a manned mission in the sense that humans are going to the space. So if it is done in the case of any accidents, we have to rescue said passengers from the space. So what we do is that we have a backup vehicle, and this vehicle has to be launched very fastly to compensate or to rescue the said people. So if we have to do that, for the production of a rocket itself, there are various stages. Okay, there is testing stage, assembly stage, the loading of the liquid fuel, then the time and place that has to be launched. So various cycles are there. Okay, each and every processes is reduced there. So we have only a particular limit or a particular time window for the rescue operation, and we have to satisfy such an operation, and for that purpose we are reducing time for each and every cycle. So maybe there will be not testing done, or there will be a reduction in the assembly phase. It will be done much more fastly by using more personnels. Okay, such and such, the time for a normal production is reduced, and it is fastly assembled for a immediate launch. Okay, so that is one of the example or one of the ways we can see concurrent engineering as. So it is such a cycle or such a process that is present in concurrent engineering. So you can see this is called a waterfall type method production cycle. Okay, you can see. So this is the original process. The processes are done in this manner. Okay, so there is a re- requirements, design, implementation, verification, maintenance. Okay, then if you are using concurrent engineering, you can see here that initial planning is inserted already into the cycle. So this is the cycle here, and without the testing, deployment is done. So there is two phases here, testing and evaluation. Now initial planning is done, then goes to the planning cycle, requirements, analyze, design, implementation, and deployment directly itself after implementation. So there is no testing and evaluation. This is then cancelled. So such an arrangement is done in a concurrent engineering. Okay. Then what are the various elements of concurrent engineering? So some of the elements are cross-functional teams. So cross-functional teams are nothing but various personnel from different area of the workplace are involved in the particular process. So I have told you the acceleration time of assembly of a rocket. So it is done by increasing the amount of personnel or increasing the amount of persons working in a specialized area so as for faster mounting of the rocket engine. So for that purpose, we are using, or one of the concurrent engineering element is cross-functional team, that is the personnels involved inside the particular process for concurrent engineering. Next is the concurrent product realization. So what is this says? It says that when we are first determining the product that has to be met up for the demand. So the demand will be very high, and we have to meet up the said demand. So that is why we are canceling some phases of the production cycle for a okay production cycle, and basically the testing and evaluating cycle we are cutting it short, and then we are going to implement the product into the market, and for that purpose it is known as concurrent product realization. So we are understanding which product has to be met up for the demand. Then next is the incremental information sharing. So in a in a industry, various fields or various departments are present, and for concurrent engineering, these departments are pooled together in a single department for accelerated production cycle. And for that purpose, information sharing is one of the basic element of concurrent engineering. So information has to be passed on very fastly for concurrent engineering. Next is the integrated project management. So it ensures that someone is responsible for the entire project. So a person that oversees the operations of inside a concurrent engineering is present, and he or she is not entitled to do the work, but oversee the procedures that are done for faster production and with better results without any fail. So if there is any fail, then we have to do the testing and evaluating phase. So we are cutting short that methods and then going on to the concurrent engineering phase. And for that purpose, a person oversees the complete operations. Then some of the challenges faced in concurrent engineering are implementation of early design reviews. So in a designing department, specific time is given for deciding idea, brainstorming, production of the design, implementing of the design, and then formation of the prototype. That is coming into the production cycle. Okay. So one of the problems of concurrent engineering is that we have to have early design reviews. So we have to, without any time itself, we have to create a design much earlier than that given in the designing period of the designing department of the industry. Okay, that is one of the challenges. Next is a dependency on efficient communication between engineers and teams. So a team of various engineers or various personnels across the industry of various departments are coming together to form the said product in a particular type. And for that purpose, there must be efficient communication between the engineers. So rather knowing rather than knowing the individual itself, we have to know the operations each and every individual carries out. And for that purpose, we have a person to oversee each and every operations. Okay. Next is the software compatibility. Software compatibility. So in an industry, latest softwares are used for production fields, especially in a robotized fields in a production robotized field in a industry. Okay, and in such a manner and all, there is software compatibility must be there, and various softwares will be handled by various departments in the industry. So once they are pulled in together, they have to have a software compatibility or the software common software that is used for concurrent engineering. Then opening the design process. So the designing process will be reevaluated and set into a new method so as to uh, produce the product at a faster rate, and each and every personnel should be aware of the design procedure and the procedures that are done for faster production, and that is also another challenge. So every process in a single department, each and every person can remember the operations that is done in under their department, but knowing all the procedures is a tedious task, and hence it is one of the challenges faced in concurrent engineering. Then three terms are coming under production alternatives. The first one is regular time production, then comes overtime production, and then subcontracting. So what is a regular time production? A regular time production is the production that we have been discussing during this entire module. So it is the production that is involved with formation of the products, for producing the products at the specific time with regular time itself. So there will be a particular time already fixed for the production of the products according to the demand, and we are producing it at that single time. And the time is never changed, and it is kept constant throughout the production cycle, and this is why it is known as regular time production. So we have discussed about a regular time production in these topics that we have discussed earlier, and next two are the situations that are changed. So the first one is overtime production. So what does an overtime production require? Overtime production is done so as to meet up the demand. So when there is a rising demand present for a particular product, okay, when there is a rising demand or the availability of the product is much less, we have to increase the production of the products. So one of the way that we increase the production is by doing overtime. Okay, we are increasing the personals for a particular time, that is basically uh, um, basically we are increasing about 10 to 20 percentage of the work hours of a personnel, and laborers are also encouraged for overtime production or doing overtime for specifically for workers that are okay. Okay, specifically for workers that are needed or they are under measly wage, so their wage will be, their wages will be very low, and they must do some more work to get the beneficial wages, and for that purpose they are encouraged for doing overtime. But law states that more than 10 to or more than 24 percentage increase in the workload in a week will result in the fatigue of a said worker, and hence it is not encouraged up to about 24 percentage increase. Okay, above that is not preferred, and hence other personals are then given for overtime production. So one of the aim is nothing but to improve or increase the amount of products that are produced. Okay, so one of the reasons or the laws that are stating for overtime production is to prevent workers perhaps out of desperation. So they are in need for money and they are willing to work at abnormally long hours, are entitled to work for overtime condition. Then to spread the available work among a large number of workers and thereby reducing unemployment. So we are spreading the available work to large number of workers. Then to compensate overtime workers for increased risk of workplace accidents they might face from exhaustion or over exhaustion. So once they are working in an overtime condition, they are given or granted a particular leave for the said work, and they are compensated for because of their increased risk of accidents or the exhaustion that they may face after the overtime condition. Then next is subcontracting. So the term subcontracting itself is meaning by uh, you are utilizing the facilities of another industry or another personnel or another production plant for producing a particular product. So for if you are making a car itself, various products are present inside a car or various components are present, and each and every component, each and every procedures or operations are done for producing the component. And a single at a single industry this cannot be happened because we have to buy or we have to have every kind of equipment for each and every component, and this may not be available, and for that purpose various components we are subcontracting in the sense we are asking or we are giving okay, we are giving the design for or we are giving obtaining the products from various other industries and then utilizing it in our product after complete assembly. So various components are then obtained from various companies and then we are pulling it into a product. Okay, so that is what is the idea or the sense of subcontracting. Okay. Now, in most cases, a company subcontracts other businesses to perform a task that cannot be handled internally. So, some tasks are present, and each and every equipment cannot be bought, or the sufficient equipment is not there to produce the component of the product. And in that cases, we are using subcontracting. And subcontracting is useful in these situations where the range of required capabilities for a project is too diverse to be carried out by a single general contractor. So we are giving it to various contractors and they do the work and then we are obtaining the component. Then it is less expensive for a contractor to hire the services of a subcontracting firm or freelancer than it is to hire an employee. So instead of hiring an employee, we can do subcontracting because primary contractor is not responsible for paying workers' compensation benefits, vehicle and commercial general liability insurance, health insurance, etc. for subcontractors. But if you are if you are employing an employee, we have to give these benefits or we have to give a fixed salary or a fixed price for his work. Rather than in subcontracting, we just have to give the money for the product's cost itself. You don't have to give it for a full time, you don't have to give the salary or the wages for the full time employee. Thereby subcontracting is less expensive. Next are the economic aspects of design. So basically there are five aspects of design. So supply and demand, scarcity, opportunity cost, time value of money, and purchasing power. So what is supply and demand? From the term itself, it is meaning that when demand increases, supply has to be increased, and when demand decreases, supply has to be reduced. So it is the production cycle. So we are producing the product according to the demand. That is coming under supply and demand. Then comes scarcity. So it is the basic problem that arises because people have unlimited wants, but resources are limited. So various products, basically quality products, are available scarcely. So when people have to buy such products, it will be scarcely available, and it will take much time for production and its availability, and that is what is known as scarcity. So that occurs when demand is high and the product is low. So such a case occurs in the economic aspect of design. Then comes opportunity cost. So opportunity cost is nothing but during the wastage of time, some work can be done to reduce or certain uh, to obtain certain amount of money from that processes itself. So maybe some time, I have already told you, during the design phase itself, some time is done for the designing process, and during that time, other departments are free. So we are allotting certain works for such departments during that time to increase the profits earned, or increase the wages or the cost that is earned during that time, and that is known as opportunity cost. Then comes time value of money. So you can see how the money with time it changes. So in older times, we had to give a lower price for a said object rather than coming into this century. So in this century, the value of money has increased rather than in the older times. So that is what is the time value of money states that. Then comes purchasing power. So the purchasing power is nothing but the products that can be purchased during or purchased by the amount of, or the cost, or the revenue that we are obtaining during each and every production and sales transactions. Okay, so according to the sales that we are obtaining, we are getting more profits, and that is what is getting as revenue. And according to the revenue, we have the purchasing power for purchasing the raw materials or the products, or consumer purchasing the product. Okay, I will wind up the class. Next, I'll take the attendance.